Hello everyone, welcome to week 11 of eDesign Computer Lab, where we are going to be covering some information about Lab 10, which will be about chapters 5 and 6 in your Autodesk Inventor textbook. Chapter 5 and 6 have a lot of information that is going to be really good for you to go through on your own. So I am not going to do the chapter walkthroughs like I've done before. I do really want you guys to go through those on your own, follow them point by point, what they do in the book. It's not going to be very helpful for me to go over that with you because it's going to point out exactly what it wants you to do. In this week for Lab 10, there is a handout that gives a couple extra instructions. There's a point where they want you to take some screenshots. I know last week I said don't worry about the screenshots. This week that is going to be important because you are going through these chapters on your own. I would like you to take those screenshots. So these instructions will tell you where and when to take the screenshots. As far as how to do that, if you are using a Windows computer, you can just hold down on your keyboard Windows, Shift, and S. And since I'm using a Windows computer, I can show you what that looks like. It'll bring up the screen where you can use the crosshair to select what you want a screenshot of. All that does is copy it to the clipboard, and you can take that and put it in Microsoft Paint. If you do and hit Control V or edit and paste, or use the paste button here, and just save that as a JPEG and upload that to Canvas. You could also paste that into a Word document. I don't really care how you do it, just something that you can upload to Canvas so that I can see your screenshots. If you're using a Mac computer, you'll use Shift, Command, and 5 to bring up your screenshot command. So this instruction at the top here will show you where and when they want those screenshots, and the assignment handout page gives you some extra information about exercise 2 from chapter 6, and I will walk through that with you because this one is a little bit of a trickier part. Sometimes these instructions are a little hard to see, and so I will go through that part with you. And that'll help us cover some of the information that they talk about in chapter 5 and 6 as well. Again, here's where you can get free access to the textbook if you don't have it. And at the end of this lesson, there are a couple things that you're going to upload. The screenshots that we talked about from chapter 5, those are in the lesson handout as far as when you'll take those screenshots. Then you will have the PDF version, as if you are going to print it, of the gasket, which is the walkthrough from chapter 6, and also exercise number 2, the shaft support, which we're going to do in a minute here. Then also, please do include the electronic files, that is the Inventor file. So when you go to save the Inventor part file, the chapter 6 gasket and the chapter 6 exercise, the shaft support. So page 6-27 has the shaft support file, so that is what we're going to do right now. I'm just going to make a new part, and because I use the default, this is probably in inches. If you want to make sure of whether it's in inches or millimeters, because this assignment should be in millimeters, this is how you can check that. Go to Tools and Document Settings, go to Units, and yes, I can see it is in inches. I want to change that to millimeters, and because I'm doing that, let's change this to grams as well for mass. Hit apply. Now my file is in millimeters the way I want it to be. I'm going to go and start a new sketch, and this is where you'll use the information that is on the assignment page, I do want to rotate this so that I can read the word top normally. I'm going to start out with some circles. The first one, I'm going to hover over the origin point, center point, until it turns green to constrain the center of that to the origin. And because they give us the values of the radius in the textbook, we want to change that to a diameter since we're drawing a circle here. Because they gave us 40 millimeter radius, it should be an 80 mil diameter. And we're going to put some circles above and below. So this is how I would prefer to do that. I'm going to make the first circle and give it the diameter of 44 mils. And then I'm going to make a second circle and not give it a diameter. So this does not have a dimension yet, but I'm going to make these circles equal. So I'll click the equal constraint, first circle, and the second one. Now they are going to have the same diameter. That way if I need to change, they can both change at the same time by changing only one of the measurements. Next, I want to get them lined up with the center. A nice easy way to do that is to make a center line. So I'm going to make a vertical line, and I want its center point to be at the same as the origin. So I'm going to click over here, get this folder opened up by clicking to the left of it, and I want to use the coincident constraint. I'm going to hover over this line until the center point shows up in green. Click on that, and then I'll click on the center point over here, and it will align those. Now if I change by dragging where one end of the line is, you can see that the top end also moves. I'm going to right click on this line and make it a construction line. That means that this line will not define any of the edges of the geometry. So when I do an extrusion, this line is kind of ignored, but it will help me to place other parts of my drawing or of my sketch where I want them. So next I'll click on the center of this circle, and I'm going to bring it over until it turns green, and you can see the coincident constraint has shown up to the lower right of my mouse, and that links the circle with the end of that line, and I will do the same thing with this circle and the top of the line. So now when I move one of them up and down, the other one moves with it. Now all I have to do is say what is that center distance that I want between them, which should be 100 mil. Now they are in the correct place where I want them. Next we've got to make some tangent lines around the outside. So first I will hover over this circle until it shows that it is going to be on the circle. It also snaps when it has aligned on the circle. And you can see the constraint also showing up to the bottom right of the mouse. But these are not yet tangent. So what I'll do is use the tangent constraint, and I can click on the circle and the line, and I am still utilizing the tangent constraint. You can see by my mouse it hasn't gone away yet, so the line again and the circle. Now that constraint has shown up in both places. That line is tangent to both circles. I'm going to do another thing here. Zoom in a little bit. I'm going to make another line that goes from one side of this circle to the other. And I'm going to right click on that and make that a construction line as well. So now I have construction lines horizontally here and vertically here. And I can use the mirror function rather than having to redraw this tangent line at all four sides. I'll use the mirror, and I prefer to select the mirror line first, so that is the center about which you're mirroring. So let's do the vertical one first. select that line, it turns blue to show it's selected, and then I will select that tangent line, it's also blue, and hit apply. Now that has mirrored the tangent line across the vertical space. Good. Then I will select the mirror line, the horizontal line now. You can barely see it, but it's turned light blue. And then I will select both of those features and hit apply. Now I have that mirrored all the way around, and I didn't have to redraw that tangent line every time. Now we will use the trim function to get rid of some of that extra geometry. Actually, let's see, one dimension is needed. What dimension is needed? I don't know what dimension is missing here yet. So what I'm going to do is use the auto dimension, just to the left of your constraints here, and hit apply, and done. For whatever reason, that tangent curve didn't appear here when I mirrored it, but now it is fully constrained. It just added that tangent constraint. I don't know why it wasn't there. It should have automatically been there. But that auto dimension is kind of nice if you see that your drawing is not fully constrained and you don't know what's missing. So let's use the trim, and I'm going to get rid of extra things that I don't need. At the top and at the bottom. And now it's telling me dimensions are needed again. And why is that? Well, let's see. This dimension disappeared. Let's put that back. Now it's showing 2 dimensions are needed. That one already exists. Again, I don't know which dimensions are needed, so I'm going to apply that. I don't know what that's in reference to, but I deleted it, and it's still fully constrained. So I don't know what that was. See, I'm not perfect at this, but the program isn't perfect either. Now, the only thing that I still need are some circles for the holes. So those should have a radius, or a diameter, sorry, of 15 millimeters. And again, I'm going to use the equal constraint rather than adding the dimension on the top one. So that way, if this ever needs to change, I only need to change it once. I am fully constrained, finishing my sketch. And I'm going to extrude that. I prefer to extrude symmetrically in case I'm ever going to use this in an assembly. And that should be 18 mils. And I forgot to select the profile that I want, so that could be important. Selected, okay. Next, I want to make the circular feature at the top. So I'm going to start a sketch, and I'm going to put it on one of the original planes here. Which one does it belong on? Well, this is the direction that I want it to be extruded. I'll put it on the XY plane. I'll make 2 circles, and by starting at the same center point, they will be concentric. They don't have dimensions yet. This should have diameter of 30, and the outer one should be 46. And I also want this to be moved over so that it's centered over this part. I can't really see my origin very well, but it does turn red when I hover over it. So I will use the vertical constraint here. And if I hover over the origin until I see it, that's fine. You can also select it as center point over here. And then that guy, now this is vertical. And the only thing left is what is the distance between the center here and the top of my extrusion. That should be 58 mils. Now that is fully constrained, I will finish this and I will extrude it. Again, I want it to be extruded symmetrically. I'll select the profile that I want here, and the distance for that extrusion should be 40. Now it's centered because I'm using the symmetric, and that is good. The only thing left is to make the feature that connects the two. So I can do that again by creating a sketch on the same plane that we just did, a sketch on that XY plane. And I'm going to project some of this geometry so that it appears in my sketch. I'll choose the outer circle here, and then the top face. And you can barely see them, but they do show a yellow line to show when they've been projected into your sketch. And then I'm going to make a line that can match up here. So I'm going to start it away from the piece, and it's going to be horizontal. Then I'll use a constraint on it to make the center of it vertical to the center point, which means that as I move this back and forth, both ends of the line move towards and away from the center. Then I'm going to make lines connecting the end to that circle up there. And I will make those both tangent to the circle using the tangent constraint. Now the only thing left to do is change the size of this. It should be 67 mils long. Okay. And then I will use the collinear constraint to make that bottom line line up with that line that I projected earlier. So now that is on the face, and it is fully constrained. I don't need to redraw the circle because I already used the project feature to put that circle as part of my sketch. So I can click finish, and I will extrude, and see I can select that profile, and it does use that circle as one of the bounds. And no, I don't want it to only go one direction. I want that again to be symmetric, and that only needs to go 18 mils. Now I've got that entire exercise done. This entire part is complete with only 3 features: the base, the circular part, and then the connector. If I wanted to, I could rename those, but considering I only have 3 extrusions in the part, it's not too tough to go through and figure out what's what if I need to make a change. Now it doesn't, right now it's not going the same direction as what you see in the textbook. That's fine. That's just the view and how it looks. So if you wanted it to go the same direction, you could use the view cube, click on the top left corner here, and it will rotate it. Now it looks exactly like what you see in your text. Hooray! So when you are done with this, please save the file and upload your actual Inventor part to canvas, and then also make a print, quote unquote print, a PDF version by changing the visual style to wireframe, getting rid of your shadows, and going to File and Print, making it a PDF. So please upload both the PDF and the Inventor file, because that way I can look at how you did it. You don't have to do it exactly the way I did. I just find that to be a very easy way to do it. If you have any questions, please let me know. I'm always available through email, and I can always talk to you through Zoom if needed too. That'll allow me to share my screen. You can share yours with me if you need to ask me a question about something that's going on in the program. Otherwise, have a great week.